All right, so this is number 37 out of chapter 2.6, page 153 in the book. They give us this rational expression, and they are asking us to go ahead and find the zeros. Well, we're going to do that, plus we're going to do a little bit more. So taking a look at this, one of the first steps we're going to go through is go ahead and try to simplify our expression. So we can simplify it by breaking both the numerator and the denominator into their factors. If we go ahead and factor our numerator, we're going to get 2x minus 1 times x minus 2. And if we factor our denominator, we'll get 2x minus 1 times x minus 3. Now the reason that we go ahead and do that is we can now go ahead and cancel any common factors on the top and bottom. In this case, it's 2x minus 1. Now, we don't necessarily want to completely eliminate that because we can use it for later, and we're going to use that a bit later to identify another piece of this graph. Not what they asked for in the problem, but we'll go ahead and do it anyway. Now, my simplified expression is x minus 2 over x minus 3. If I'm looking for the zeros, then I'm simply looking for when this expression, which is f of x, is equal to 0. Well, this expression will be 0 if the numerator is 0. So to find the zeros, all we do is take our numerator, x minus 2, and see when it is equal to 0. So I add 2 to both sides, and I get x equals 2. So x equals 2 is going to be one of my x-intercepts, or 0. Zeros. Now, I also find that this x minus 3 is an important piece. That is when my graph will not exist, and it'll act something like a vertical force field so that when my graph approaches it, it will be repelled, and my graph will consistently approach it but never quite get there. And so x minus 3 equals 0. When that's equal to 0, or when x is equal to 3, I will have a vertical asymptote. Okay. So we have two important pieces. Now I'm going to go back to the piece over here. Now you might notice that when 2x minus 1 is equal to 0, well, then we're going to have a 0 for a denominator. So our graph doesn't exist at this point, but since we were able to cancel it with our simplified expression here, it doesn't create an asymptote. What it does create is a hole in our graph. You can verify all of this on your calculator, and I recommend doing so you can get a visual image of what we're talking about. But at x equals 1/2, you will see a gap in your graph. X equals 2, our graph will cross the x-axis. And at x equals 3, you will have a vertical asymptote, and you'll see that the graph is kind of pushed away from that, and our graph will approach x equals 3 but never quite get there.